Welcome back. Here we are in the third section of this course, working with high-level APIs. As you realized so far, working with TensorFlow Core is not a trivial task. There are a lot of details that make TensorFlow different from using other libraries from Python, and it can be somewhat difficult for the beginner. However, for common machine learning tasks like regression and classification, we have high-level tools that can essentially perform the same computations with much less code. In this section, we introduce these high-level APIs, so let's see what we are going to do in this section. In the first video, we will introduce Keras, a very popular high-level library for deep learning in Python. Keras uses TensorFlow as backend and provides a much more user-friendly interface. In the second video, we perform our regression example using a high-level estimator class called DNN regressor. Similarly, in the third video, we run again our classification example using the Higgs boson data, this time using the pre-built DNN classifier class. And in the fourth video, we talk about the wide and deep model, which is another interesting type of model that has been implemented in an easy-to-use high-level class in TensorFlow. Finally, in the last video, we provide some advice on how to customize some of the elements in your deep learning model. So this is the plan for this section. Let's get started. How to use Keras for building deep neural networks. Okay, this is what we are going to do in the video. First, we are going to give a brief introduction to Keras. Then I'm going to show you how to build a DNN or a regression task using Keras. And finally, we will review the recipe for building a regression or in general a supervised learning model with Keras. Okay, now let's talk about Keras. Keras is a high-level neural networks API written in Python and capable of running on top of TensorFlow, CNNTK from Microsoft or Theano. The default backend for Keras is TensorFlow, and this is how we are going to use it. However, you can use the same Keras code and it will work on CNNTK or Theano. So there is no need to change anything in your Keras code if you are going to use other backends. So that is a big advantage. Keras was developed with a focus on enabling fast experimentation. As the author of the library says, being able to go from idea to result with the least possible delay is key to doing good research. For this reason, Keras was built with the principles of user-friendliness, modularity, and easy extensibility. Now, to install Keras, simply run this command with the created virtual environment activated. So just go pip install Keras and you will be able to use Keras within the virtual environment that we have been using so far. Okay, so to use Keras, the sequential model is perhaps the easiest way to build deep neural network models with Keras. It consists of a linear stack of layers. So you create your sequential model and then you add layers sequentially to it. And after the model has been built, before training, you have to configure or compile the learning process. So you must specify which optimizer you're going to use, the loss function, and a list of metrics. And then for training, you use the .fit method, similar to scikit-learn if you are familiar with that library. And then the model will fit the data to the neural network to learn the weights and biases. One of the objects that you will always use when using a sequential model is this dense layer. This is the most commonly used type of layer. So this layer, you must provide the units, how many units you would like your layer to have. These are the layers that are the building blocks of the neural networks. By default, you don't have any activation function, so you must specify one. By default, you have a bias in each dense layer, and the initializer for the weights of the layer is the glottal uniform. The bias is initialized with zeros, and you can easily provide some regularization for the weights and some regularization for the bias if you would like to do it. Okay, so the sequential model and the dense layer are the key elements that we are going to use in this simple example. Now let's take a look at the code. Okay, this is the Jupyter notebook that contains the example code for this video. Basically, I am going to reproduce the same model that we built before using TensorFlow core. We are going to use the diamond prices dataset, and we are going to build a deep neural network to predict diamond prices. So it's basically the same model, but now using Keras. So the first step, as you may guess, is just to load and prepare the data. This is basically the same cell we used before. So in this cell, we prepare our 4 objects that we need: the X train, the X validation, the Y training, and the Y validation. At the second step, when using Keras, or at least in the way we are going to use it, is to instantiate a sequential model. So we import from Keras.models, we import the sequential class, and then we instantiate in this object that I am calling here reg model. The third step is to build your DNN using dense layers. So from Keras.layers, we can import this class dense, and then we can, after defining the architecture for our network, we can just use the add method to add the hidden layers for this network. Okay, so we are going to be using the dense. And for the first, one thing that you have to keep in mind when using this sequential model is that you must provide the number of inputs for the first hidden layer. Okay, so that's why we are providing here this additional argument here. Now for the following hidden layers in your network, you don't need to provide the input dimension because they will be inferred from the dimensions of the previous layer. And finally, here our last layer has no activation function because this is a regression task, so in this case no activation is applied. Okay, so this is the third step. We have built our DNN model, and then the fourth step is to compile the model, and here is where you provide the loss that you are going to use, the optimizer. In this case, we are going to use the mean squared error. The optimizer will be the Adam optimizer, and these are, you can provide a list of metrics by which you want to evaluate your model. In this case, we're going to use just the same, just the mean squared error. Okay, then after deciding the number of epochs and the batch size for training, you use the .fit method. We pass the X train and the Y train and the number of epochs and the batch size, and then the model will, Keras will start training the neural network. Okay, so after training, and this, well, this of course depends on your machine and depends on the size of the data. After training, you know, the model will be ready, and you can use the predict method to get predictions. Okay, so in this simple line of code, as you can see, I am getting the predictions from the model, and then I am just doing the same plots we did before for visualizing the predictions versus the observed prices. And here we have a histogram of the absolute values of the errors from the validation dataset. So this is how to use Keras to reproduce the model that we built in TensorFlow core. As you can see, well, it's much easier and it requires less code, and it's basically doing the same learning, the same computations. Okay, great. So now let's review the recipe we saw in this video. The first step is always to load and prepare the data. Then you instantiate a sequential model. The third step is to build a DNN model using dense layers. And then in every dense layer, you choose with the number of units and the activation you will use. The fourth step in Keras is to compile the model. And here we set the loss, the optimizer, and the metrics. Finally, we train the model using the fit method. And after the model has been trained, it can be used to make predictions, and then you visualize, analyze the result of your model. Okay, so in this video we provided a quick recipe for building a DNN using Keras, and it was relatively easy to do, so that's why this Keras library is very, very popular.